question 42. You have a cyclist travels along a horizontal road, so like this, the variation with times t of speed v is shown in the figure. So you have a figure that looks like this. You got a v graph against time, 0. The cycle maintains a constant power, so throughout this, power is constant. And after some time, reaches a constant speed of 12 meters per second. So this graph is actually for 12 meters per second. So this is showing the initial, I guess. A, describe and explain the motion of the cyclist. Okay? We have to describe and explain the cyclist's motion. We only have a VT graph, so let's start on. Notice the velocity. Slowly, it does not, compared to a linear one, so you got a linear graph like this, VT. We say the velocity is increasing at a constant rate, but this one is not increasing at a constant rate. It actually looks like as though it's slowing down. So the first thing we mentioned, as the speed increases, what happened to a resistance? A resistance increases. If A resistance increases, when we are putting in constant power, what happens to the resultant force? Our resultant force reduces. Because why? Constant power means driving force is constant. When driving is constant, when A resistance increases, your resultant force therefore reduces. Hence, the acceleration is less. As shown by here. How do you see acceleration in the velocity time graph? Remember, you're looking at the gradient. And you can see, if we're comparing the gradient at the beginning, at the middle, and at the end, you notice gradient to acceleration. The acceleration is actually decreasing. Why? It is due to resultant force decreasing due to air resistance increasing. Then they mention something in the question. We must mention that as well. So what happens here? Why do we reach constant speed? Constant speed occurs. Constant speed when resultant force is 0. Okay. When resultant force hits 0, you have constant speed. So remember, last time we did kinematics about terminal velocity is what is actually occurring here. When it reaches to terminal velocity, means the resultant force is 0, means your driving force is equal to your air resistance or your frictional forces. Okay. Now we go to the next question, B. When the cyclist is moving at a constant speed of 12 meters per second, so constant 12 meters per second, the resistive force RF is 48 newtons. Show that the power of the cyclist is about power is equal to 600 watts. Explain your working. So here, the explain working. Y in this case, our speed here is we got speed of 12, and then with 48, we have the power cyclist about 600 watts. So quite easy. In this case, we got power equal to work done over time equal to twin of work done is energy. So energy over time times force times velocity. In this case, we'll use P is equal to Fv, and our F here, our force here is 48 newtons times by 12 meters per second. That calculated with me, but you calculate with you, when a positive value of is around 176 watts. If you check the previous video, we only use this. Why? Because they did mention constant speed. Constant speed is when your driving force is equal to the air resistance, resulting in your resultant force equal to 0. Therefore, in this case, since they are equal to each other, the only force we need to tackle is only frictional force. Now moving on to the next part. C. Use figure 42 to show the acceleration of cyclists when speed is 8 meters per second is about 0.5. So at v equal to 8.0 meters per second, you want to find acceleration, which is a show question. So a is equal to 0.5 meters per second. So we already know what to do. So you locate your graph at 8 meters per second. Let's say we're going to redraw this. Let's say here is time with the 8 seconds. You want to find the acceleration, means you have to draw a tangent. So you draw a tangent. Apologies. Tangent. There you go. Draw a tangent here. After that, choose 2 points. And then your gradient is equal to your acceleration. Put in your 2 points. 2 points, unit 6 meters per second for v, and then you got seconds. Since it's a graph, and you will get the answer gradient, therefore when I pause this video, you should have a range of between 0.44 to 0.48 meters per second. So this is, which is close to 0.45. Okay, so hopefully you get somewhere in the middle, 0.46, and then you understand why 0.5 meters per second. D, the total mass of cyclist's bicycle is 80 kilograms. So total mass 80 kilograms. Calculate the resistive force R acting on the cyclist when speed is 8 meters per second. So you have to find R when his speed is 8 meters per second. So it comes to this question. Remember, the fourth question, use a diagram. Choose direction positive to be forward. So you have the driving force. You have to find resistance. So resultant force is equal to MA. Resultant force is shown by here, which is driving force positive minus R equal to your MA. Therefore R, bring this to the other side, R is equal to FD plus MA. Okay, so with this, what's the next step going to be? You already know what is the information that you have given here, which is you have a constant power of 600 watts. So how are we going to use this in the question? Power is 600 watts. Power is equal to work done over time, energy over time, force times velocity. So in this case, we want to find a force, your power over velocity. Power here is 600 watts. What is our velocity in this case? Your velocity here is 8. So far we have resultant force is equal to MA, our first force equation. Previously, we have seen work done is equal to force times displacement. Our next force equation was work done over displacement. Now remember, if we have power, if we need to find what our driving force is, we have another equation, which is P equal to FV. That means F is equal to P over V. That means for 3 equations we can use. 600 over 8 for your driving force, because this is the power used to drive the cycle. Your M here is 80, gotten here, a short question, so please use the exact value they want, which is 0.5. I don't have a calculator with me, so please calculate this. Once you finish calculating, you should have a value of around 32 newtons. But you have to be careful here. Bringing this becomes positive. Bringing this actually becomes negative. So always double check your sign so that the physics makes sense. That means residual force, you have the driving force, and then the thing required for acceleration, and you have the difference between them will give you the resistance. Residual force in this case is the 2 newtons. Going to question E. Use the information given in B, which is 12 meters per second, residual force is 48 newtons, power cycle is about 600 watts, and the answer to D, which is the residual force is now 2 newtons, is that so they want us to literally compare this. We are at 12 meters per second compared to 8 meters per second. So you can see proportionality is starting to form. To show that in this situation, the residual force R is proportional to speed V. R is proportional to speed V. You need to show this. Okay, so how do you show this? Quite straightforward. At 12 meters per second, R is equal to 48 newtons. At 8 meters per second, R is equal to 32 newtons. Therefore, if you want to show that they are proportional, all you need to do is change this into R is equal to Kn, Kv, and therefore K is equal to R over V. K1 is equal to 48 divided by 12, which is equal to 4.0. K2, which is 32 divided by 8, is equal to 4.0. Since K is a constant, since K1 is equal to K2 equal to K equal to constant, therefore R is proportional to V. A tricky question. We have found another equation for force. So please remember, if you give power, you can actually find your force there. We are talking about proportionalities, so sometimes we direct questions here, which you just need to show the constant of proportionality. After that, everything will be fine. And gradient and explanation. So I hope you understand this video. If not, please replay this video.